For most of the world, agriculture has a hard stop. When severe winters or deep dry seasons hit, the ground freezes or parches, and food production completely shuts down. But India's massive landmass spans two completely different climatic extremes: deep tropical weather in the south and subtropical to temperate zones in the extreme north. Instead of limiting what can be grown, this dramatic split in temperature creates an environment where farmers can plant and harvest without taking a single month off. To manage this diversity, India divides its year into a strict three-part cropping calendar: Kharif, Rabi, and Zaid. This three-season structure transforms a complex geographic anomaly into a system where planting and harvesting occur in every month of the year. The cycle begins with an overwhelming injection of water. Every year, massive tropical monsoon systems arrive, slamming the coasts and sweeping across the subcontinent. This marks the start of Kharif, the summer cropping cycle. Farmers time their sowing precisely to catch the very beginning of these monsoon rains. The strategy here is to plant crops that require intense, heavy hydration. That means vast fields of paddy, maize, jowar, and bajra. Relying heavily on tropical rainfall, highest yields come from regions directly in the monsoon's path: Assam, West Bengal, coastal Orissa, Andhra Pradesh, Tamil Nadu, Kerala, Maharashtra, UP, and Bihar. In Assam, West Bengal, and Orissa, saturation is so ideal, farmers pull 3 successive harvests yearly. These 3 distinct rapid-fire paddy crops are locally categorized as the As, Aman, and Boro cycles. It is highly labor-intensive work. Workers wade deep into the floodwaters to plant bright green paddy shoots directly into the submerged soil. By the time September and October roll around, the heavy rains have also fed massive industrial cash crops. Workers begin harvesting raw cotton by hand from dense, leafy green bushes. Alongside cotton, farmers pull in vast quantities of jute, organizing the tall, thick stalks into bundles along rural roads. The Kharif season is entirely built around capturing the volume of tropical monsoon water to generate massive staple and commercial yields. But between October and December, the monsoons recede. The landscape visibly dries out and the temperatures drop. This transition initiates the Rabi cycle. This is the winter cropping season, operating on an entirely different logic than the flooded summer fields. The agricultural center of gravity shifts to the extreme north and northwestern temperate zones, activating states like Punjab, Haryana, Himachal Pradesh, Jammu and Kashmir, Uttarakhand, and parts of Uttar Pradesh. These colder environments support a completely different profile of crops: wheat, barley, peas, and gram. It also brings sweeping visual changes to the landscape, as vibrant yellow fields of blooming mustard take over the winter acreage. The challenge is hydration. With the monsoons gone, these crops survive through unique atmospheric anomalies called western disturbances, weather systems that deliver specific bursts of winter rainfall. Because that winter rain is only partial, these northern states rely on artificial means of irrigation. Farmers draw from engineered canals and distributaries to keep the fields alive. The cycle wraps up between April and June, when the weather warms again and farmers head into the parched fields to harvest the dry wheat stalks by hand. Rabi proves how human engineering and localized atmospheric patterns can be combined to exploit a cold, dry northern winter. This leaves a narrow, hot window between the end of the winter harvest and the return of the summer monsoons. This brief sliver of time is the Zaid season. The strategy here is speed. Farmers use this intense summer period to push fast-maturing crops out of the soil so the land never sits idle. The outputs are mostly water-rich produce meant to survive the heat: watermelon, muskmelon, cucumber, various vegetables, and quick-growing fodder for livestock. There is one major exception to the fast-growth rule of Zaid season: sugarcane. While sugarcane is planted during this short summer window, it demands almost a full year to reach maturity, towering over the farmers who planted it. Zaid functions as a high-speed bridge connecting the 2 major cycles, preventing any gap in the nation's agricultural output. A chaotic mix of tropical and temperate geography could have fractured a food supply, but instead it was integrated into a unified system. This chart shows exactly how synchronized the system is. The Kharif cycle absorbs the summer monsoons. Rabi utilizes winter western disturbances and strict irrigation, and Zaid fills the summer gap.
Because of this precise geographic and chronological mapping, there is never a moment when the soil is entirely at rest. By working with climatic extremes instead of fighting them, an otherwise volatile geography results in a relentless, year-round harvest.